Okay guys, just as I promised, I'm going to talk you through the practical that we did in our lesson the other day. And that practical was investigating how temperature affected the rate of an enzyme-controlled reaction. Now the enzyme that we are using is trypsin, okay, at 2%. And I've already measured 2 centimetres cubed into this little glass vial here, okay? Now, trypsin is a protease enzyme that breaks down proteins into amino acids, and the substrate for trypsin, okay, is casein, which is in milk powder, okay? So in here, I have measured out 3 centimetres cubed of my milk powder at 3%, okay? So here I am already controlling the volume of enzyme and the concentration of enzyme, and I'm controlling the volume of substrate and the concentration of substrate, because those can also affect the rate of an enzyme-controlled reaction, okay? pH can also affect the rate of an enzyme-controlled reaction, which is why I have added 2 centimetres cubed of pH 7 buffer to make sure my solution stays neutral, and I added it to my trypsin directly. And what I'm doing at the moment is I'm waiting for my enzymes to get up to temperature. So they are in a water bath at the moment, which is currently around 45 degrees. It was 50 degrees, okay, but we're waiting for another couple of minutes to ensure that my enzymes and my substrate are up to temperature, okay? Now, how we are measuring this rate of reaction, we are actually measuring the time. If you have a look here, you can see that there is an X right at the bottom of my glass vial. Now there is one underneath my milk as well. And I want to time how long it takes for me to see clearly that X through my milk powder, okay? And as soon as I can see that X, I'm going to stop my timer, okay? So as soon as I add my enzyme to my milk, okay, I am going to start my timer, okay? And I'm going to do that now. So I'm going to take 2 centimetres cubed of my solution, okay? And I'm going to start my timer now. Okay, so remember we're timing how long it takes for me to be able to clearly see the X at the bottom of that glass vial, okay? So 50 degrees is the optimum temperature for these enzymes. So we're in between 40 and 50 degrees at the moment. So we should be expecting this reaction to be quite fast. At the moment we are around a minute's gone. Hopefully we should start seeing some digestion soon. Okay, I can start to see some lines through it. So it is going. Getting clearer. Now obviously at 50 degrees we would expect to see a much faster reaction, but that's one of the issues with these water baths, is that we can't control or maintain the temperature. We could do this in a thermostatically controlled water bath. Just can see the X now. I'm going to stop. Okay, ideally I'd like there not to be as much white, but I can see the X, okay? So 2 minutes, 19 seconds at about 44 degrees, okay? Now, The issue with these is that obviously we can't maintain the temperature of the water. You can keep adding hot water to top it up, but that means that the temperature is going to fluctuate between anywhere here. So from here it could be to 45, it could go up to 55, okay, and that's above my optimum temperature. So if I want to maintain a constant temperature, then the best thing to do is to use a thermostatically controlled water bath, okay, which we have at the side, which continues to monitor the temperature and increases and decreases the heat respectively, okay? Now the issue that we have with that is, all right, and I'll show you right now the issue that we have with this, wait a second, is that this is our thermostatically controlled water bath. Now the problem that we will have is that we would find it difficult when this is filled with water. Okay, you would find it difficult to see that colour change here, okay? So you can now fully see that has fully digested the casein and I have a colourless solution, okay? But it'd be really hard to see this colour change happening in this thermostatically controlled water bath, which is why we tend to do our practical with this setup, okay?